Hi students, welcome to Alpha C learning program. Mathematics, we are in parabola, and earlier we have done oblique parabola, some concepts as well as problems also. Let us discuss today students about the parametric coordinates in parabola. Okay, parametric coordinates actually you have observed in case of circle they are coming in cos theta, sin theta, etc. Again in case of ellipse and hyperbola also we can observe about trigonometric functions. Whereas in parabola only we are not taking any trigonometry function, we are just taking here in terms of a real number which is known as a parameter. T can be any real number, T can be even 0 also, which is of this form. If I substitute for x is 8t square, it is 4a square t square, then 280 if you substitute here 4a square t square. That means we are taking just like this a form that is 80 square comma 280, where here t is any real number. If t is 0, then it is 0 comma 0 which is vertex of the parabola, right? And now what about here the observation of these two parabolas? We know clearly these two parabolas are images of one another with respect to the line y equal to x. Therefore, if this point is of the form alpha beta, then immediately this point is of the form beta comma alpha. That's why we got 280 square. If you put x is 280 here, 4a square t square, whereas here again 4a square t square. And next one, here and here the only observation is we are replacing x by here minus x. Everywhere a value is positive. So replacing x by minus x if I write, then this value is here minus 80 square. The only difference is here x coordinate is negative. So minus 80 square to 80, t square positive, a also positive. Therefore this is our value. And if I put here x value minus 80 square, again you observe 4a square t square, this side also same. In the same way, this also we can observe these two are again images of one another with respect to the line again same. Therefore, just we have taken interchanging, that is 280 comma minus 80 square. So students, these are actually our parametric coordinates when the parabola y square is 4ax or anything. Suppose if we are having the parabola where here origin is shifted to any other point alpha beta. That means here you are having equation y minus beta whole square equal to 4a into x minus alpha, right? Suppose the equation is like this. Then actually this is our parametric form 80 square to 80, whereas in this form the vertex is nothing but alpha beta. Therefore simply you have to add these alpha beta values to this one, that is 80 square plus alpha comma 280 plus beta. These are our parametric coordinates for this kind of parabola. In the same way here and here also we can apply, just use here the concept of here translation of axis, and this one just t is the parameter, add alpha here, beta here, as vertex is how much here, alpha comma beta, right? And now whenever a point is given on the parabola, suppose we have taken this is y square equal to 8x parabola. Okay, y square is 8x parabola, and I am taking here a point 2 comma, when x is 2, y value is 4 or y value can be minus 4. Suppose 2 comma 4 is a point on this parabola. How we can write the t value, the parameter value? We compare these values with this 80 square to 80. Then what is 4a value here? 4a is equal to how much here? 8. That implies a value is 2. That implies this is nothing but in what form? 2t square comma 280 implies 4t. That implies if you equate these two values, you have to observe here carefully. If you equate these two values, that implies t square is 1 and hence t equal to plus or minus 1. Whereas if I equate these two values, you are going to get how much? T equal to 1. Now what is the common value from these two? It is t equal to 1. Therefore, in this case, you have to take t value how much here? 1. Okay. So, like this here, to obtain t value, because some formulae related in terms of t. So, we want to substitute exactly t1, t2 like that. Therefore, we need to compare with the standard parametric coordinates, and you need to write. So, here you have to observe carefully the common value you have to consider, which is nothing but in this model it is 1. And suppose the parabola is coming as here x square equal to 4ay type. Suppose this is the parabola and a point x square is 4ay. Suppose I am taking the point as here minus 4. Understand? So minus 4. So let us write here this is some 16y. Then if it is x is minus 4 here, y value is plus 1. Okay, so I am writing a point in this way, 16 equal to 16. Then what will happen while taking here parametric coordinates? For this actually the parametric coordinates are 280 comma 80 square. That implies 280 here comma 80 square. And in this one, what is our 4a value? 4a equal to 16, that implies a is equal to 4. Therefore, here this value is nothing but 8t comma how much it is? This is 4t square. So, a value 4a is 16 here, implies a equal to 4. 280, that is 8t comma it is 4t square. Now if you compare these values here, first value minus 4 equal to how much here? 8t. Okay, minus 4 is equal to 8t, that implies t equal to minus 1 by 2. If you compare here abscissa value minus 4 and 8t. And next if you compare the ordinate value 4t square is 1. So 4t square is 1 implies t equal to plus or minus 1 by 2. Now again you got t is minus 1 by 2, t is plus or minus 1 by 2. Therefore finally the common value, that is nothing but minus 1 by 2 you have to consider. In this way actually before you observe comparison, better avoid here comparing the second degree value, because anyhow you will get here plus or minus cases. Therefore always you compare only first degree. Therefore whatever the value you are getting, that is the final value. Understand students, why we are doing this is now some formula are coming in terms of t1, t2 like that. Then you must identify easily what are those kind of values. Okay, so this is regarding the parametric coordinates of parabolas under different conditions. Okay, now let us observe here, just like our circle chapter, after the first one, that is different forms of equations of circles. Here also different forms of equations of parabola, we are going for notation. So s value we are taking here, y square is 4ax. So whatever the concepts we are going to study, these will be same even while coming the chapters, so that is in ellipse as well as hyperbola also. Different forms of ellipse and after that notation. So here also same thing. Now this is our standard form, y square minus 4ax. Standard form we are taking, and now S1, this is for any point x1 comma y1. If at all you choose, then second degree reduce as y by 1, and the first degree value you have to take exactly half the value. Exactly half means in this one you are taking half of the value, and this x value first degree you have to express sum of the values x and x1, whereas second degree you have to express as product of the terms y and y1 or x and x1. So second degree it is coming as product, whereas first degree it is coming as always sum. Moreover here you have to consider exactly half the value. And next one, S2 value. How you are taking here S2? Just here instead of suffix 1 we are taking suffix as 2. That's it. And S12. S12 means here 1 every value is there. So extra suffix you give here 2, that is y1 y2 and x1 plus x2 as it is everywhere. S11. Here instead of 1 2, okay, 1 2 we'll write, or one more also 1. So replace wherever 2 is there, replace 2 by 1. So that is nothing but same given standard equation, directly you are substituting here y1 square minus 4x1, that is S11. Of course, you have seen already all these in the previous chapter, circles. Now sometimes we come across not only this one, the second degree non-homogeneous equation also. That is, suppose S is given as ax square plus 2hxy, okay, plus by square plus 2gx and plus 2fy plus c. Suppose this is our second degree equation in x and y. Homogeneous you take or non-homogeneous, as a whole I am taking. Now for a point x1 comma y1, how to write here S1, okay, how to write S1. So here S1 is again second degree x square, can be written as xx1, this is product. And next one, it is xy. So xy is coming, whenever xy both are coming, both are variables here. So take exactly half the value, h into, just like your differentiation, you remember, it is x into y1 plus it is x1 into y, okay. And in this way we can write. And next value, it is plus by square, that is b into y square, we can write y1. And plus this, of course you know very well, it is half x plus x1. And next plus f into it is y plus y1. Half the value, first degree value, first degree, so half. And plus c constant as usual. So this is S1 students, whenever non-homogeneous, again x square xy also present, just remember half the value and remember as a differentiation product rule kind of formula. So this is S1 value, because now onwards frequently you have to find tangent equation or chord of contact for different kinds of curves, then directly you can make use of S1 value, okay. So these are regarding notations. After notation, as usual, our concept is nothing but position of a point with respect to the curve, okay. So suppose we are taking a point P of x1 comma y1, okay. Now the parabola, actually total plane, if you observe, suppose this board you consider as a plane, the parabola, it divides in three parts. One is, it is inside, this total part it is known as inside the curve, and this entire other part, this is known as outside the curve, and this is exactly on, okay. So now whenever you consider any point P of x1 y1 with respect to a parabola, suppose s equal to 0, what about its position? Is it outside, or is it falling inside, or is it exactly on the parabola? Then how to check? In case of circles, we compared distance from center and radius, d greater than r, d less than r, d equal to r. Whereas here we are not having any radius, center, etc. So we are going in a different way. Let me take here the standard form as s is y square minus 4ax, okay. So this one we are taking y square minus 4ax. Concept we can applicable, once we derive the concept, it can be applicable for any type of parabola also, okay. Now let us take here y square minus 4ax. Then this point, suppose this point is outside somewhere here, x1 comma y1, okay. Now once the point, if I consider there, now clearly you can observe this point is outside the parabola in the plane. Now whenever it is outside, what about the condition we are going to deduce? Exactly here to this point, exactly here you consider a point, understand, exactly at this point, suppose it is Q, okay. Now once this is here origin, the vertex it is origin, and now exactly here I am taking the point, therefore as we are taking perpendicular to the axis, therefore here the abscissa value is same, that is x1, okay. And now what about ordinate? It is some other value y2, okay students. Now therefore Q of it is x1 comma y2. Now the point P can be here, then also we take, the point P can be here, then also we take. Now in this stage actually the ordinates we want to compare. So how are ordinates here? y1, this total length, it is more than compared to this ordinate length. Suppose you may get doubt, if P is falling here, okay, y1, and here suppose you got this is the q value, suppose it is a value you got here minus 7, then this value is suppose minus 5, then we can't say this is more than or less than. That time we have to take only lengthwise ordinate, lengthwise, that's why we use here mod of, okay. So mod of we are taking, so in general what we are writing, it is mod y1 is greater than how much, mod of y2, wherever the point P is here on the plane outside the curve, okay. Now once this is the value, we are doing square both the sides, okay, y1 square is greater than y2 square, and now here what is y2 square, this point is on the curve, therefore it has to satisfy the equation. So it is y2 square minus how much it is, 4a x1 is equal to 0. That implies y2 square is nothing but how much here, it is 4a x1, therefore we are taking this is here 4a x1. So y1 square we got how much, greater than 4a x1. So if I take this side, y1 square minus 4a x1 is greater than 0. That implies it is nothing but s11. So s11 is greater than 0. Same concept I think you remember in case of circle also, whenever s11 is positive, the point is outside the circle. So here also same, students, same concept will continue even in ellipse also, only in hyperbola it differs. Therefore whatever the standard form here you are considering, s is y square minus 4ax or x square minus 4ay, understand, like that here standard form, some second degree equation in x comma y, if at all you have taken as yes, then s11 if you got positive, then the point is coming here outside the curve. If it is on, this of course we know all of you, whenever a point is on a curve it has to satisfy the equation. So on means s11 is 0, and in the same way if you consider the point P of x1 y1 inside, what we write here, instead of greater, now we write here less than symbol, therefore you will get s11 value less than 0. So same concept whatever already you have studied in circle, here also moreover s means here you consider a second degree equation, that is a homogeneous or non-homogeneous curve, a second degree equation, then s11 greater than 0 implies the point P of x1 y1 is outside the curve, okay, outside s equal to 0, and if it is coming as equal to 0 that implies on, and if it is less than 0 that implies it is coming inside the curve s equal to 0. So this is the notation as already we have discussed in circle, same thing you will get even in ellipse also, okay students. Now students, let us observe what about equations of chord as well as focal chord in case of parabola, okay. Suppose we are taking the standard form parabola equation, y square is 4x, and all of you know if 2 points x1 y1 x2 y2, a of x1 y1 comma b of x2 y2, if these two are points on the curve, then the segment AB is known as here chord of parabola, okay. Same concept in any kind of geometrical figure. Now here AB is here, this segment is here chord, then our interest is what about the equation. If it is given in numerical values, you know what about here equation of line joining 2 points, obviously we write y minus y1 is y2 minus y1 by x2 minus x1 into x minus x1, that is nothing but here equation of line joining 2 points. But here if you take the curve here, s is some value, standard form y square equal to 4ax or x square is 4ay, whatever you have considered y square minus 4ax, not only in parabola students, even in circle, hyperbola, ellipse, everywhere, the equation of chord joining 2 points, the notation is nothing but like this, s1 plus s2 is equal to s12, okay. But while doing numerical problems we don't suggest here to make use of this formula. So the proof as it is here, however we have taken, that is y minus y1 y2 minus etc., but we convert all the values in terms of s. So this is the formula for chord joining 2 points x1 y1 and x2 y2. Okay, and now what about here our interest in terms of parametric coordinates. Suppose I am taking here parametric coordinates, that is here a of 81 square comma 281, and the other value is nothing but b of a-t2 square comma 2a-t2. Okay, suppose we are taking parametric coordinates. Now in this case, what about equation of chord joining 2 points? A very important concept, students. Now onwards, whatever we are going to derive, chord, focal chord, tangent, etc., these are all very important points. Now what is the standard equation we have taken here? Y square equal to 4ax. So this is the standard equation. Basing on this, now our interest is to find equation of chord joining 2 points. Then as usual, 2-point form line equation we take, that is y minus, it is 2a t1, okay, equal to y2 minus y1. So if you take 2a common, it is t2 minus t1 divided by a into t2 square minus t1 square. This side you start, or other side it is t2 minus t1 and into t2 plus t1, and into the value is how much here? X minus a-t1 square. So this is our equation of chord joining 2 points in parametric form. Now here we can cancel a value and t2 minus t1 value, thereby that is nothing but slope of the line joining. So one of the important concepts you have to notice here, that is slope of chord joining 2 points is nothing but 2 divided by t1 plus t2. Just now I have showed you, whenever a point is given like 2 comma 4 and 2 comma minus 4, and if you know about this, directly we will write in terms of parameters also. Of course numericals directly also we can write. And next another one is here, what about complete equation? So what is the equation now? It is y minus 2a t1, okay, is equal to 2 divided by t1 plus t2 and into it is x minus a t1 square. Now let us do here cross multiplication, that is y into t1 plus t2 and minus 2a t1 and into it is t1 plus t2 equal to 2x minus 2a t1 square. So this is equation we are expanding, and now observe here, this is minus 2a t1 square, which we can cancel with this value, and left over I am writing it is y into t1 plus t2 is equal to 2 into x plus a t1 t2. So this is nothing but equation of chord joining 2 points. Understand all of you? So what about for y square is 4ax parabola? If these are here parametric coordinates, the equation of chord joining 2 points is nothing but y into t1 plus t2 is 2 into x plus a t1 t2. It is must and should one has to remember this formula, because every time it is not sufficient time we are having to deduce again the formula. That's why in parabola, students, equation of chord, equation of tangent, normal, one has to remember. Not only s1 is 0 in terms of parametric also. So now this is our equation of chord joining 2 points, and this formula exclusively for what? Y square is 4ax. Then what about the other kind of curves? Same kind of formula. Okay. Now if I take the parabola, this is y square is 4ax we have taken, and what is the formula we have deduced here? Line joining points, it is y into t1 plus t2 equal to 2 into x plus a t1 t2. Okay, so one formula if you remember, students, you can write it for any other curve also just by remembering this one. Suppose it is x square is equal to 4ay. If at all you got this kind of curve, understand? Then what about chord joining 2 points? Then just interchange here x and y. That only we have observed, these two are images of one another with respect to y equal to x. Therefore just interchange these two values, then you will get here x into t1 plus t2 and here 2 into what about this y plus a t1 t2. Just interchanging of these two. And next one is what about y square is minus 4ax. when y square is minus 4ax, here just you write the value minus x, okay, and x square is minus 4ay, then just write this value as minus y. That's it. So once you remember one formula, easily you can write the other values also. Next one, our interest is what about length of chord, okay. So now let's find, students, about length of the chord. So this is length of chord joining in terms of parametric, length of chord joining 2 points in a parabola y square equal to 4ax, okay. And again I am telling, suppose a problem is given, numerical values given, you can find just a distance formula to obtain length of chord. But many problems in parabola, actually the theory part is more compared to the numerical part. That's why you should know about the theory part very well. So whatever formula we are giving here, just please practice all this very well. Now this is the point here, how much? A of at1 square comma 2at1, and this is b of at2 square comma 2at2. Just we are finding, students, now length of the chord joining 2 points. It is nothing new formula, it's just our distance formula only. So what is the formula here? AB equal to nothing but we are using distance formula, under root of it is a square, okay, at1 square minus at2 square whole square, and again plus it is 2at1 and minus 2at2 whole square, okay. So just a distance formula only we are applying, and thereby this is nothing but under root of a square here, so you can take here a common, let it be mod a, or you can put it as a, because a we are taking every time positive. And now this is t1 square minus t2 square you are having. I am writing it as t1 minus t2 and into t1 plus t2, okay, whole square is there, so here 1 square, here 1 square, and this is t1 minus t2 whole square. In this way we are writing. Now let's take again this value also common, but you don't know exactly t1 greater than t2 or less than t2, therefore here we have to put mod symbol, a into mod of t1 minus t2, and the rest of the value if you write here, of course here 4 also there, so we write here 4, and now the rest of the value if I write, it is t1 plus t2 whole square plus 4. So students, this is formula for length of the chord joining 2 points t1 comma t2 in case of the parabola y square equal to 4ax. Suppose you take the parabola x square is 4ay, okay, then what about parametric coordinates? These are 2at1 comma how much it is at1 square, and here it is 2at2 comma at2 square, okay. Then also you are going to use a distance formula, that implies just in the reversal order will get, but here anyhow plus symbol is there, implies same formula even you can apply for x square is 4ay also. Understand? So this is length of chord formula we have derived. Next one. So observe, students, let's observe this problem. This is length of chord of a parabola y square is 4ax. Now what are conditions given? That chord is passing through vertex, okay, chord is passing through vertex, and the chord is inclined at an angle of theta with axis of parabola. Then we have to prove the length of chord is nothing but in terms of cos and cosecant square, okay. So what is equation of parabola given? Y square is 4ax. This is equation of parabola, and now here the chord is passing through this vertex, okay. Anyhow it is line joining 2 points, therefore one point is fixed here, that is this is here vertex 0 comma 0, and the other point let us consider this as here b, and this b coordinates let's take in terms of parametric, that is 80 square comma 280, okay. So in terms of 80 square 280 we have taken. Now our interest is AB value, but they are not asking in terms of t, they are asking in terms of theta. What is the given condition here? This chord, whatever the chord we require length, that chord is making an angle of theta with axis of parabola. So we know clearly to this parabola this is our axis, and with this axis it is making what angle? Actually theta, right? And now this value we want finally in terms of cos theta, cosecant theta, etc. But just now we found here actually equation of chord formula. That formula I am not using here directly, very easy. Just by using right angle triangle we can get. Let us drop a perpendicular here. Then what about these coordinates here? It is 80 square comma 0. Understand? Now what about here, as tan theta is the slope, I want to find t value. Okay. So what about here, these values here students, this is 80 square, and what about here, this value actually it is nothing but this is 280. Okay. Now what about here, tan theta? Observe, our interest is actually AB value. Okay. To obtain AB value, first I want to find what is exactly t value in terms of theta. Okay. Now from right angle triangle ABC, tan theta is equal to, how much it is here? ABC tan theta equal to, this is equal to opposite side, that is 280 divided by 80 square, implies it is nothing but 2 divided by t. Okay. So tan theta you got 2 by t, and then here our interest is AB value. So if you use a distance formula here, AB is nothing but under root of a square t to the power of 4 plus 4a square t square. Okay. Now let's take here a square t square outside, and therefore it is a, and this is t value. Okay. And inside it is nothing but how much actually? It is t to the power of 4 means t square, and plus this value is 4. Right. So we have taken a square value, t square value outside. As it is length, therefore you consider it as t positive I am taking. Now a into t, how much is the value? It is 2 divided by tan theta. Okay. T by, this is t is 2 divided by tan theta. And again here also I am substituting under root of t square plus 4. So what is t exactly students? It is 2 times cot theta if I write, then this is nothing but 4 cot square theta plus 4. Okay. So this is the value you can obtain here, 4 cot square theta plus 4. Now let us simplify the value completely. So if you do simplification, this one, it is 2a divided by tan theta. That 2a divided by tan theta, let us write it as 2a and into cot theta. Okay, 1 by tan, it is cot. And again this is 4 cot square theta plus 4. So 2 is coming out. Cot square theta plus 1, it is nothing but cosecant square, and thereby we write it this value as here cosecant theta. Okay. Now angle we have taken actually acute, so everywhere I am putting here positive, or else we can put complete value in terms of mod symbol also. Now this is 4a we got, understand, but the answer is cosecant square. Therefore I am writing this as cos theta divided by sin theta, and into it is cosecant theta. Hence this is nothing but 4a, the value it is cos theta, and 1 by sin is nothing but cosec. Therefore you got here how much? Cosecant square theta. Hence what we got students from this one, actually it is not a big problem actually, just based on distance formula, and at the same time taking tan theta from the right angle triangle, and thereby we substituted t as how much here? 2 cot theta in this one, thereby you got here this type of value. Okay. So what is the nature of the chord here? The chord is exactly passing through the vertex. Okay. Chord is passing through the vertex, and that chord is making an angle theta with the axis. That implies tan theta is the slope. That also you can find here directly. Slope of the chord also you can use, instead of using right angle triangle, here I can use directly slope also. Okay. So this is the first problem. Now let us observe students the second problem. Here in second problem also they have asked about length of the chord. Okay. In second problem also they have asked here length of the chord, but how is the equation of parabola? X square is 4ay. Okay. X square is 4ay, and it is passing through the vertex, just like our previous problem. The chord is again passing through the vertex, but again it is making an angle alpha. Okay. Inclination, not with the axis of that parabola. You have to observe here carefully. For this parabola axis they did not give. directly they give slope is nothing but how much? Tan alpha. Okay, so now if this is our parabola, students, x square is 4ay and this is our x axis. Okay, and this is origin. And they said here the chord is passing through the vertex. That means if this is the chord, it is passing through the vertex. And now let us take this point again here, B of, and in this one x square is 4ay. The curve is x square equal to 4ay. Therefore, what are our parametric coordinates? 2at comma 80 square. These are our parametric coordinates. Now here, what is slope of line joining AB? Understand, because we want here, they said the inclination is nothing but how much here? Alpha. That implies slope directly given as tan alpha. So slope of chord AB, okay, slope of chord AB according as the formula, it is nothing but 80 square divided by 280 according as formula. But what is the value given? It is given as tan alpha. So directly in this problem, the slope of chord which is passing through the vertex is given directly tan alpha. In previous problem, they said theta is angle made by the chord with the axis of parabola. But what happened there? The axis itself is directly their x-axis. Whereas here they are not mentioning with axis of parabola. If they mention axis, it is nothing but y-axis. That's why in this problem they gave the slope of chord of parabola is tan alpha. Now here let's cancel a and these values also. Therefore, how much we got here? This value is nothing but it is t divided by 2. Okay, so a cancelled, 1t cancelled, finally you got t by 2. So t by 2 equal to tan alpha. That implies what is t value? It is 2 tan alpha. Now just like our previous problem, let us find here distance between A and B. So what is AB distance here, students? The AB distance is nothing but here it is equal to under root of, what is the value? It is 4a square t square and plus the other value is a square t to the power of 4. Okay, so this is our distance between A and B value. So 4a square t square plus a square t to the power of 4. And after that, suppose you substitute wherever t is there 2 tan alpha. Before that, let us take here a square t square common, just like our previous problem. So if you take the value common, so AB is equal to, how much we are taking common? A square t square. Then you will get a into t and under root of, this is 4 plus how much we got? A t square, just like our previous one. Now a into t means what is the value? 2 tan alpha. And next here it is under root of 4 plus 4 tan square alpha. So that the value is nothing but here 2a, and again from here 4 another 2. So 4a tan alpha and into this is 1 plus tan square alpha. Therefore this is nothing but how much? Secant alpha. 1 plus tan square alpha. And if you at all you want to simplify, this is 4a sin alpha divided by cos alpha. So 4a sin alpha secant square alpha. However options is given, we arrange like that. Okay, so now whatever problems we have done till now, those are just 2 chord lengths we have found for different parabolas where the chords are passing through vertex and inclination given in problem and another problem directly slope given. Okay.